Okay. We're in the house with a closed loop system. We're running SSG and SSG gen mode in a series connection to see if we can't stay on top of the barrel here. We're at 12.79 in the battery. We're going to try and stay there. Yo, yo, what's up? How's everybody doing? We're doing a closed loop system, and we're at 12.79. It's been there since we started, pretty much. I think it started at 12.80, but you know, you got to spend one to get one. So, but now we're getting like more than one when we're spending one, so that's awesome. We're not ahead, but we're like right there. And the reason I think it's like that is these cap banks that I put in the middle. So really what that battery's doing is it's siphoning off the cap bank. There's like an even flow. Let me show you how I'm doing it now. There's the 120 magnets on the rotor, right? And then 180 magnets, so those coils will never be on at the same time. And one of them is dumping, and the other one is taking from the battery. Dumping to and taking from. There's only one battery in this equation, right here. We have 230 ohms of base resistance.
I'm getting a vibe on failure of membership. I'm saying, would you like to start a cross and not get how much as you can?
Okay, sounds good. All right, so you got your basic bifilar situation here. You got your trigger strand and your drive strand. This is not your basic coil though. You got two of those setups in that coil complete. You got two triggers and two drives in the coil. Right now I'm only using one of those drives. And as you can see, like right here, those wires are just sticking out there. So I'm gonna hook a back EMF collection on both of those wires. But right now they're not hooked up, but I will hook them up. Because they're just sitting there. They might as well be doing something, right? 12.79. Still. Welcome, everybody. So how's it going? Thank you, thank you. All right, I'm going to put this in a tripod. I think I might be shaking around too much. Yeah, maybe not, you know. Sorry. It's going to be a total mess putting that up there. And each coil for each circuit has got strands that I can hook up for BEMF. They both have, that's a 4-filer coil and this is a tri-filer coil. So there's extra wire there that I can apply. Now, will that make more energy? I don't think so. In my experimentation, what it does is divide the energy that's there. Um, that's just the way it is. You get a little bit more, but it doesn't, in the end, add up to be more. It's not like you get more gen on your battery for it. It's not like you get ahead for you doing it. I'd love to see that and how to do that, but so far I haven't been able to get ahead on the charge without, something being wrong. But we can get unity pretty much, just not a charge. Haha. And that's cool, man. This is just for, to see what's going on. I'm not a teacher, so I'm not going to pretend to be a teacher. So, I'm just telling you what I've done, what's going on here. I'm not telling you how to do anything. But if you can gather what's going on from what I'm telling you, then maybe, yeah, maybe I could. I don't know, though. All right, so this SSG it's got that coil. It's connected to that coil. And then its output is connected to this cap bank. And this cap bank is connected to the input of the SSG gen mode over here. And its output is connected to this cap bank. And that cap bank is connected to the battery. And we're managing to stay at par. It hasn't, I don't think it'll go down really for a while. Closed loop system, ladies and gentlemen. Closed loop system. This is the output for the circuit on that side, and this is the output for the circuit on that side. They're pretty equal, within a volt of each other. But the reason I have this circuit hooked up to begin with is because its output is greater than this one's output. But this one's drive force is way greater and costs less than this one's drive force. So when I hooked them in series, you get the drive force of this one and the generation power of this one with one battery. So there's no give here. I'm taking everything. Now there's 3 magnets in the rotor, and I got the magnets at 180 degrees so that neither one will be on at the same time. Now it's not a full 90-degree separation, but it's separated. So I'm going to see for myself whether or not this will work. So there's 230 ohms on the SSG with gen mode. And there is, let me see here. That's 1,000 ohm potentiometer. That's almost all the way. So that's like 800 ohms. And then 230 ohms. So 1,030 ohms of resistance on the SSG right now. 1,030 ohms. My fault. Look at how fast it's moving, man. I don't need to take ohms off. That's going to make this number go down. Why would I do that? It's moving for how many ohms are on this thing. It's really moving. I think it's great. I think it's freaking fabulous. Fantastic. It's awesome. Yeah, it's ghetto, but it's awesome. Let's get that underbelly shot real quick. Look at that. That looks clean as hell, man. That looks really neat. Almost equal on the air gap. It's pretty nice. I don't know what to expect right now, whether it's going to go up or down. It's pretty stable, I'd say that much. Huh. So there's got to be some sort of amplification going on in the closed loop in order for there to be any kind of over unity. It's got to be amplified. So there's got to be some sort of transformer in there somewhere, right? I mean, that's what I would assume. A step-up transformer somewhere that will, but you know, the amp, you know, it all depends really whether you need amps or volts. The energy to be in amp form or volt form for your battery. The SLAs really respond well to amps. So, I don't know, I mean, you would probably want a cap dump. Maybe a cap dump will work well for this. Steady as she goes. So this is the output of the one circuit, and this is the output of circuit number 2. So we put this output into circuit number 2, and this is what comes out, okay? So I don't know if either one of these numbers are well enough to go over unity, but they're well enough to do what we're doing right now. Because circuit number 2 utilizes the back EMF spike and circuit number 1 does not. It's because it puts a drag on the drive. The spike does. It makes it so like this circuit will always be faster than that circuit. So I'm using this circuit primary for the speed, and then I'm putting its output into that one to boost the output. And then I'm using this coil to time that circuit to be on when this one's off. If you get me. So it'll charge the battery at least as much, if not more, than what's being spent. And right now it seems to be pretty equal. You know what? I don't care what other people said. I don't care what's been done already. I don't, it doesn't matter to me. That matters very little to me. I'm gonna do it anyway. You know, I'm gonna like do the experiment just like we're doing it right now. I bet there's somebody out there saying there's no way this is gonna work. I've said it 100 times. There's no way this is gonna work. But it doesn't mean I don't get to do it and show you guys what I'm doing, right? I mean, right? Yeah, that's what I'm doing. This is how we do. And, you know, all this is a culmination of about 2.5 years of just messing around. But this thing right here is something. It's a toy that I've basically unified. Whoa. No, I can't really tell because it's the energy is obviously moving to the thousandth of a volt. So I can't really tell which way it's going, but I would say it's going down. That's how I think. It's definitely going down, but I mean there might be some instability that every third spin it goes up a little bit, and but the other two spins it goes down. So inevitably it's going to go down, but there's that we're in a period where it's going like this, like a frequency, like a wave. Yeah, we're just collecting data for sure. Seeing, oh, you know, and one, you know, I got to be a certain level of reality. So do you. Now, my time is not as valuable as I would like it to be at the current point in time. But you know, we're getting there. Steady as she goes, right? Steady as she goes. 12.79. We'll just call it 12.79. Was obviously looped up because that would have been dissipated such a long time ago. Yeah, I've turned off my chat. I don't want to see anymore right now. So, uh, keep up the good work, though.
Mhm.
Yeah, there's so much stuff that I don't even like. It doesn't make any sense, and it doesn't matter really. It doesn't matter to me whether I call it a neutrino or whatever. You know, we're talking sunshine. That's what we're talking. It's all right, man. Even if I'm just jumping in a big, you know, around dancing around a bonfire by myself, I'm cool with that. But I would like to share the experience with some people. I mean, this is probably going to stay like this for another hour or two. I gotta plug in my phone. There we go. Wow. Pain in the ass. Oy. All right, I suggest we ask questions about pulse mode.
Okay.
Good idea. There's not enough people. Nobody even wants to touch that.
Right. Victor says, what's going on here?
It's a closed loop system. I would say it's close to unity. It's not over unity or anything magical, but it's close to unity. It's been at 12.79 on the battery for the last hour, hour and a half right now. And it's running. So I'm gonna get the shot like that. I like this shot. All right, so we're about to break it down again. God, I wish I had some water. Coffee will have to do. All right, so we start here at the battery. And there's one battery in this system. So we go from the battery to the input of the SSG, and then the output of the SSG circuit from kenergy.store goes to this cap bank. And the output of this cap bank, which is DC, will always be DC, because there's bridge rectifiers in the middle here, those 4 black boxes right there. And the output goes into the input of that SSG with gen mode. And the output of that goes to this cap bank over here, sorry. And that cap bank then connects back to the battery. And voila. All right, now for resistance, we have 230 resistance, base resistance on both circuits. Right there, right there. And then the SSG has a potentiometer. The other circuit does not currently. It's the cap banks that allow you to connect all this stuff together. I mean, there's probably other pieces of equipment that will allow you to connect this stuff together, but the cap bank works just as well. I think a cap dump, if you're going to add anything else to this, a cap dump would be what you would add in between the cap bank and the battery. And I would put a cap dump there. That's what I would do. But as for right now, it's working. It's working pretty well. 12.79 still. This is the output of the SSG. And this is the output of the SSG with gen mode. So you gain about a volt by doing this. And then the trigger for the SSG is offset at 180 degrees. So these two circuits are pulsing on and off, which is allowing the battery to catch up. Now it's not a full 90-degree pulse. It's not 90 degrees. And then 120 on the magnets. So it's a little less than that, but I'm going to see if it works. And my objective currently is just not to go down. We're trying not to go downwards in voltage. If we go up, then we jump for joy, but we're trying not to go down.
All right. In a nutshell, what are you trying to make?
I've made it. It's a closed loop system. It's made.
Move deeper. That's jargon.
I don't understand what the question is.
So it's always got it. I'm just saying, if there's people that don't know
What it is?
what a closed loop system is.
Oh, it just means there's one battery. You're charging one battery and you're using one battery to run the system.
That's all I was getting.
Yeah, all right. So yeah, that's what that means. The closed loop system means you're running on one power source and you're charging that same power source. That's the closed loop.
All right, and then I got a whole question up about, would you rather have a round rotor or not round?
Oh yeah, that's a great question.
Not round, 100%.
Not round. Okay, what then? All right. Now you have to exemplify what that means.
So I know, I was thinking about like the fan one, but what about an oval?
Yeah, if it was a perfect oval, I bet it could. It would shake probably miserably. But hold on, let me get mine. I mean, it's not round, but it is definitely from a circle. I mean, if you understand what it is, you're gonna make it a circle.
A circle.
So if you don't understand, you're gonna make it whatever you want it to be.
Something else.
But I don't understand either, man. See, this is my not circle one that I made. And it's attached to the rotor, so.
Like,
But when you spin it, you can see that it's definitely a circle.
that's sweet. Right, but it's got those, accents.
It was born a circle, but yeah, it has an accent on it. Because you want it to not create friction with the air around it. So you want it to be round. Do you have to make it round? No. Like this one. There's a 12-sided shape. It's not a circle, but it is round.
Mm-hmm.
It's pretty neat though. This one really moves, and it's north-south, north-south. So it's really good rotor. And if somebody's thinking toroidal, I want you to show me how you're going to make that work. I had a great idea for a toroidal system. I never followed through with it though. I changed it to something else before I finished it. But this right here is a huge neodymium magnet that I was going to have in there, and then have it spin like this, the center in the middle, and then yeah, let me show you. God, let me show you. This right here is the toroidal. So there's nothing like holding it in its toroidal position, except when I put the drum on. Oh man, I had such a great system. But I need to remake it because now this toroid is got 64 sides to it. And now Tinkercad does 128. So I'm going to do that and probably remove the coils that are in here and redo this one, because this will work, man. It works pretty good. And it's a counter rotator too. Not only is it toroidal, but it's a counter rotator. I added this black part to create stability, but there's another way to do it where you're not really connecting the shaft to it. You have 4 mini shafts is what you have. Yeah, it's awesome. I might actually do that. I might actually build that, like rebuild that toroidal and change the magnets, the electromags. That'll be fun. But these actually, where there are the stands for them, right here. And bearings will go in these holes, and then rods will go through the bearings, right? And then the toroidal will rotate on those 4 spokes. As long as they're hard enough not to bend. You know, as long as there's no bendage in them, the system works pretty good. And then I had it so perfect, like mathematically so sound, that I had to buy these little tiny bearings. Here's one of them. To fill in the gap that was between the toroid and the little rod that it was sitting on. All right, so basically you had the rod going through the stands right there, and then you had this on the rod. And the toroid would sit right on these bearings, and then it would spin very easily. All of it could spin. It was all spinnable. I mean, that part could spin, the rods could spin, everything could spin, and that was the whole what? No. Okay, just go. My kids don't know how to be in trouble. That's for sure.
Yeah, but he's grounded. He's asking you to go outside.
Yeah, he doesn't know what being in trouble is all about. He's wondering why he is in trouble. You know, he just doesn't understand that daddy doesn't have to be rational all the time. As a matter of fact, as the older I've gotten, I found it more and more impossible to be rational all the time. You can't do it. I mean, you're gonna fly off the handle one time or another. And there's two types of people. One that flies off the handle often, and then one that just saves it up for grand finale and just boom. There's two types of people.
Passive aggressive. And those that talk about it.
Yeah, the ones that don't talk, and those are the ones you gotta watch out for, I'll tell you. Yeah, man, because they're sitting on something. There aren't people out there that don't have something. There's something out there for you, even if you haven't bumped into it yet. Absolutely. So this is a closed loop system. We start at the battery. We go into the SSG. We go out into the cap bank, which has bridge rectifiers. So it's all directionally guided at this point. There's a diode in the SSG circuit, so it's all being directed in one direction. Okay? From the cap bank, we go to the SSG gen mode, which does not have its own power supply. It's getting its power from the output of the SSG. And its coil is hooked up 180 degrees to the SSG's coil. Okay? There's 3 magnets in the rotor at 120. So when this one's on, this one's off. And this one's off, this one's on. Right on. Okay.
Right on.
From the SSG output, we go to the cap bank over here, and then from the cap bank back to the battery. Since there's all the bridge rectifiers in here that you could possibly want, there's no backlash from the battery to the battery. All the circuitry is taken care of, basically. Then we got a potentiometer. We got 230 ohms of resistance on both circuits, and then a potentiometer on the SSG. So, and it's right where it needs to be right now, I think. Let's see if we dropped one. Nope, 1279. Oh yeah. I charged that battery last night because I wanted to get a good jump on this experiment right here. So this is the output of the SSG. This is the output of the SSG with gen mode.
Yes. That was perfect.
So we get a little bit more out just for putting it through that circuit. And it's timed differently than this one. So it's not like there's a conflict at the battery for power going in and out and whatever. Really, I think that all the power currently is in a loop. Okay, so on the battery, it doesn't start and stop at the battery anymore. It's just looped. And that's why it's not going down. Without the cap banks, though, it wouldn't be this way. It wouldn't be like this. I mean, you might be able to put a bridge rectifier, just one, in place of the cap bank, but why would you do that? Probably because it's a lot cheaper to get one of those than it is to get one of these. Be a good reason to do that. And I'm pretty sure it would work. It might even work better. You know what I mean? But currently I only have one to play with, so I'm not even gonna mess around with it right now. Now, I got a lot of stuff that's useful that I'm not gonna use. So yeah, I'm just sorting through all the stuff that I've got, and I've got some stuff that I might want to like let go of. So in the next couple months, I'm going to be sorting that stuff out.
I wonder if a triangle rotor work.
Yes. Depends on the triangle. If it's a, what is it, a isosceles triangle?
Right.
Yeah. If it's an isosceles triangle that's balanced out properly, I'm sure it would work just fine. Absolutely. That's actually something that I might want to try. Equilateral?
I think it's both, but I gotta remember.
It's not an isosceles triangle, because I think that's the tall one.
Well, so that might be a physics thing, so you might be right on that.
Yeah, I don't think the isosceles triangle is going to work as a rotor, though.
Same.
Yeah, if you got the triangle with all the sides that are equal length,
Yep.
then you can make that into a rotor.
They have cups at the end. Yeah, that would be hard with the CAD.
No, no, but you couldn't make it a triangle. You'd have to like cut off the ends of each.
Okay, right.
It couldn't be pointy. If you were going to put magnets on the tips, it wouldn't be pointy anyway.
So it'd be like that sounds cool, a triangle.
Yeah, it looked like the Alienware symbol, maybe.
Yeah, that's what I was saying, like a rounded, yeah. Like
Yeah.
That's a good thing. So, three sides with two flat ends for sure.
No. Yeah, man, what I could do is I could make another like rotor like the one that I showed you earlier, but like flatten out the edges. That one right there. Yeah, it's cool, man. That one's designed for cubes, neodymium cubes. You know what I could do? Is I could put one more cube on these stacks and put this rotor on top of that third one, then you'd have a space in between them, in between the two pieces of plastic. I don't know if that, you know, means anything or anything like that, but you get what I'm saying, right? Just make that magnetic strength in there a little bit better, a little bit more strong, a little bit more easy to trigger, you know? You can either make your trigger strand longer or you can make the magnetic strength stronger. Boom. Then you'll be adding weight too, which will be awesome.
Says that looks killer.
Thank you. So I had what I consider to be a brilliant idea. It doesn't seem, it's not hard to do once you've done it, you know, and it's not hard to know once you've done it. But I've always known the SSG to be great speed, but little shy on the output. So we take the output from the SSG, we put it through a cap bank, and then we run the SSG gen mode with that energy. Okay, and then the SSG gen mode spits out more energy than comes out of this one, just from what we put in that one with this one. Okay, are we good? All right. So that's awesome. That means, yeah, you start out with 12 volts, but you only get 2.5 out. It gets stashed in here. You run that with 2.5 and get 4.5 out. And that gets back to the battery. And then the timing of the coils is real important. Nope. Oh, 7/8. It's going. It's going. Oh, it's going. Let's see. What time is it?
101.
So like an hour. It took an hour. Maybe I can make it go longer if I turn the resistance up a little bit. Yep, it's going to go for a little bit longer, but you see how the resistance will make the number go up again? If you add more, doesn't mean it's charging. That's not charging. That's taking that 1 volt on the top and stretching it out. That's what that's doing. But I love it, man. It's great. Because I've run it like this 20 times, maybe. And every time I can make it go back up by tightening the knob. Lefty tighty. No, lefty loosey. So it's exactly the opposite. I start with it turned all the way to the right, and then I get it turned like all the way to the left, and that's where we are right now. All the way to the left. That's between 900 and 1,000 ohms. So altogether, that would be in between 1,200 and 1,150.
10 legs.
Hey.
Yeah, plug it in.
Huh?
Get the plug.
All right. Hey, yo. It's Papa Bale. What's up? Please like, subscribe, hit the notification bell. Tell your friends and family. Join up. Become a member. It's all good. We like to keep it real and have a lot of fun at the same time. So come on down. Yeah, that's about 900 ohms right there. This meter is dying or dead, so I'm not going to mess with it.
Not gonna mess around.
Now, what I could do is I could move that multimeter over here to monitor the battery, and we could get a look at the wave that this thing is producing. How about we do that? I just want to move the multimeters around real quick. So, And I got a cap going across the battery to keep that.
Thousand views.
Alrighty, hey. Welcome everybody, it's Papa Bale. Welcome to the channel. Like, subscribe, hit the notification bell.
What project are you working on from John Morris?
I need to make sure I'm doing this right. I'm hooking up a multimeter right now. But it's a closed loop system. Alright, that one's hooked up. Now I need to hook this one up to the battery. I'll go through it in just a second. Lost my balance there for a second.
Careful now.
Alright, let's. Alright, so it says the battery's at 12.86 with this other meter. We'll see what's really going on in a second. Look at that, man. That is fabulous. There's like, I don't know how many spikes there, but it's amazing. About 17 to 18 volts peak to peak, though. And that's on the SSG. That's awesome. That's got a lot of speed for how many ohms is on it. A lot more noise to the motor today than there was yesterday, though.
The noise.
It makes you wonder, doesn't it?
Yes.
What-
There's a mouse in
It's a mouse in it. There's a hamster.
there. Hamster squeaking in the wheel. Not real. No hamsters or mouse for real.
Wow, if anybody took that seriously, I don't even know. That's a beautiful wave, though, man. That is awesome. All right, I'm not gonna mess with it. It doesn't want to zoom in. Looks like the battery juice is going up, guys. But I did just tighten the knob a little bit, so that might be what's going on here. But it said 8.4. Now it says 8.5.
Charge.
Huh. That's breaking the rules. Nope, take it apart. Take it down. That's Gerald.
Okay.
One more thing. It's already charged. Been experimenting with some splicing of my full-length videos, and I think it's been going pretty good so far. Just to break it down, get the information going in different feeds. So, like, if you don't like doing shorts, this is perfect for you because it makes your long videos into short videos. But it was an experiment, and we'll see about what's going on with that. But it's on hiatus for the current time. So these spikes are each like 17, 18 volts. Nothing major, but I think they're pretty good. What I'm saying, the hypothesis that I want to put forward is that these spikes would be twice the size if I put these strands in series with these strands and connected it back to the circuit. Because it would be twice as long, the trigger strand would be twice as long. That'd be literally putting two of those circuits in series. But is that really what we need? Do we need all that voltage? Be nice to have, and they're just, the strands are just chilling there. So That's probably something that I'll do is I'll add those strands to the SSG. And if I'm going to do any BEMF additions, that will be off the 22 gauge strand on this coil. Just the one. And the way I figure you do that is you put your diode across the coil in parallel. So negative to negative, positive to positive. And then you connect your negative end to, I believe, this is where I get confused. Whether you connect it to the negative or the positive or the negative end of whatever you're connecting it to. But I know you take the negative end then and you can connect it to whatever you're going to connect it to. Like if you had more than one BEMF coil, you probably just attach it to the next BEMF coil at the positive end, or in series, really. But yeah, that's one thing I want to do. But like this is the battery's voltage, and it is not going down. It wants to go down. It's gonna go down. But right now it's pretty stable. And then it's like, see, this is it though. This is the thing. If I hook up those strands in series, it's gonna take that much. What is it? More amps? It's gonna take more amps to run it, or it's gonna take less amps. See, I think I should put those strands in there, like right now. I took them, I had it like that, and then I took them out and I put those strands in the other circuit, and I got some really good output, like, really good. Wondering if I should do it again now, I don't know. Which way should I go? Should I just leave it the way it is? Looks like it's doing pretty good. Maybe a poll on that, bro. That'd be cool.
You gotta tell me what it is.
Okay, okay. Hold on, let me think. Should I leave it the way it is, or should I mess with the wires? And I'll wait to get a response on that a little bit. Let's see what time it is. There we go.
And we got 6 votes on the last one, 50-50.
So we're just gonna let So what I'm going to do, if we mess with the wires, is I'm going to elongate this circuit's wiring by 2. 2 times. It's going to be 2 times the length. And I'll be hooking up a diode to the trifilar strand of that coil over there.
You got no answers so far.
Yeah. It's all good. I think we might just leave it the way it is. 'Cause it is working. Oh, there it goes. It's going.
Welcome to the stream.
Welcome. Welcome, everybody. This is Papa Bale. And we're taking a look at the closed loop system. And right now, we're currently doing pretty well. I mean, it is going to drop. We just saw it dropping. 12.84 is our next digit. There it goes. That took a while, though. Like, but what I'm proposing is adding length to the coil that's in the SSG and adding a back EMF collection diode to the 20 gauge strand in the coil of the SSG gen mode. So if you want to vote as to whether or not I should do all that, or we just let it be. We can let it be too, man. And 0 votes means we're letting it be. Perfect. Yeah. So I mean, this is exactly what you are to expect from the system like this, is that it's going to go down, but it's going to go down slowly. I mean, the only place in the system where we get a gain, and it's a small gain, is from the output of the SSG to the output of the SSG gen mode. You gain about a volt right there. But, you know, I think I need to get a potentiometer for that circuit, and then maybe we'll be somewhere. But, you know, I just have one for this circuit. All right, it's a closed loop circuit with an SSG and an SSG gen mode. We start at the battery, we go into the SSG, we go out to the cap bank. From the cap bank, we go to the SSG gen mode input. And then from that, we go to the cap bank. The output goes to the cap bank. And then the cap bank is then connected back to the battery you started at. So, I mean, it took me like forever just to be able to figure out how to connect the battery to the battery basically without it sparking up and and everything else. So I was ecstatic when I finally figured out that it just took a few directional, um, you know, pieces of equipment to make it happen. And now it's happening. It's happening the way it, you know, it has happened always, going down very slowly. And there's the wave. I'm not sure exactly how many spikes are in each one of those waves, but it's a lot. And because it's only half a coil, we only get half the voltage. So it should be up around 35 volts. And the coil is like mirror image of itself. So it'll be exactly 2 times that, what it is right there. And then if I take the BEMF, Wow, look at that. That's freaky. It's pretty neat.
Alright, we got 1 volt. And that's with the wires and the top on it.
Okay. All right, so one to go, and so we're gonna go. All right. Thank you. All right, drive strand is done.
We are messing with the wires, and then we'll talk about the changes.
Okay. Clip. There it is. Now I gotta elongate the or the trigger strand. Because you want to have a full interaction through the whole coil. You don't want to have just half of it interacting. Hopefully I got this trigger right. Or I'll have to redo it. And that just, these things are tiny.
Josh is in the house.
What's up, Josh? Help us that. Oh. Oh, I need that. All right, so we got our elongated coil here. Let's see what happens. I want to hook up this first though. So like if you only have probes for your multimeter, you can clip a clip to the probe and well bam. Yeah. Ugh. All right. Little itch. Itchy. So that's working pretty well.
It's working. All right. I'm gonna hook up the back EMF on the 22 gauge now. All right, so we got our diode. Just Schottky diode. Somebody think I have some other diodes that I can use. I got 1400N7s or something. I got those little ones. I've got 1000 volt 3 amp ones. Okay, now I just have to. All right, so I've connected the negative end, the cathode, to the end of the coil, and I've connected the positive end, or the anode, to the beginning of the coil, where you started and where you finished. Easiest way to keep track of that. And then if you can remember which way you spun it,
clockwise or counterclockwise, that helps too. It should be really easy to tell this, which way, where you started at. But if it's not, that's okay. Sometimes it isn't easy. It's only easy if you make it easy.
Working easy.
Nice. Why did that light up?
Why did it light up?
Yeah, why did that light up? Let me see what's hooked up to it. Holy cow. I might have been making a big boo-boo. I think I have it all hooked up, right? Not a big boo-boo, but, you know, like, there's a lot of yellow and black cords over there. So let me make sure that I got the right ones hooked to where they need to be. Oh my Lord. Yeah, that's kind of embarrassing. I'm good.
What does it do?
We're gonna see in a second.
Sunshine. The creation.
Hmm. That's interesting. Oh, I do remember having it that way though. Bingo. So I think that's awesome, man. That's really cool. I guess this is classic. $17. So I guess I was wrong about the doubling of the voltage. I just remember it being like that. I don't know why. Might have been the fact there was no resistance or something, some other fact. But that it applies over all instances is not a fact. Only sometimes. I figured it out. I keep on missing like one thing because I'm so tired.
We got it.
We got it. Alright, so now I need to work with that BEMF diode over there. Now, you can either hook it up in series or you can hook it up in parallel.
Oh, this is a pulse motor.
Yes. It's a closed loop pulse motor.
Oh, it's on the title. Can you see the title where you're at? $2,000 views.
I heard a change. Definitely a load on there now. What we're looking for is for this to go up. Nope, now it's not gonna work. Alright.
Urban Parker. Something about a dial.
Yeah?
They had a diode on the power feed wire going in from the positive.
The positive power feed wire? Yeah, I just blew some stuff trying to do this.
But a load has to be put on the charge side or it will destroy the transistor.
I'm pretty sure all that stuff is taken care of in the SSG circuit. Right here, it's all taken care of. We got diodes and reverse diodes, we got resistors, we got more diodes. It's all good. Sir, I appreciate you. But right now I'm just trying to collect BEMF off of one strand and plug it into the battery that I'm using. And that's right here. So what I'm gonna do is maybe collect it in series. Right? I don't know. I'm not sure exactly how to connect this to the battery, so I might not even do it.
That sounds like a cool band name. Connected in series with destroy the transistor.
Yeah, I don't want to talk about broken transistors right now.
Broken transistor. Sorry.
Man.
He's like, they're a raw material, they're a component and all this, and they cost money.
Yeah, and they're protected too.
Like and subscribe. Super chats are appreciated. We buy transistors with those.
Yeah, thank you.
Thank you, thank you, thank you.
I'm Papa Bale. Thank you very much. Yeah, like, subscribe, hit the notification bell. Make sure that I don't have what you suggesting that I need already, because I think I'm pretty sure I got all that stuff here already. And I don't want to mess it up, you know what I'm saying? Because it's working just fine.
Don't wanna mess it up now.
Don't want to mess it up. I might blow everything right now trying to hook up this BEMF, but I'm stupid. I'm trying to hook it up while things are running. That's ridiculous. Oh man, I think that I did that the last time. It didn't work out so well.
the last time it didn't work out. Thank you for the likes.
Thank you all. So what I want to know is where I clip these two clips. Right here, one's at the positive end of the diode, one's at the negative end of the diode. Where do these clips go? Here, let's try this. Put them on a bridge rectifier. Right? Keep the direction going the right way, and then we'll clip it. Gotta clip it. I'm just gonna make sure.
The power has to be changed in rotation again through AC 470 volt, 80 microfarad
No.
cap, then back to the SSG. Oh, we have to, we'll be running
No.
down here.
Yeah. Sorry, one more time.
No problem. The power has to be changed in the rotation again through AC 470 volt, 80 MFD cap, then back to the SSG.
Why? I have two cap banks in the circuit already. All right, I'm going to explain the circuit real quick. You got your battery. It's 20 amp hours, 12 volt battery. Goes to the SSG and runs the SSG. The SSG is basically what's running the motor because it runs better than the SSG with gen mode. So the power goes in here, it goes out the output of the SSG circuit. And if you need a close-up of the circuit, I will show it to you. All that stuff you're talking about is already here. It's already here. And the output goes to this cap bank right here. And then this cap bank, the output of it is connected to that SSG with gen mode. So whatever output is coming out of the SSG is running that SSG. And it works. So you can't tell me you can't do it because you can do it. I'm doing it right now. Okay, now there's two coils involved here. You got one coil for this and one coil for that. They're offset. Okay, so when this one's on, this one's off. When this one's on, this one's off. All right? That's all taken care of. And then that SSG gen mode dumps into another cap bank, and then from that cap bank back to the battery. And then the cap banks will take AC and DC and turn it into DC. Pure DC coming up to one side. Now what was I doing?
Messing with the wires,
Mm-hmm.
and then you were gonna talk about it.
No, I was hooking something up. Oh yeah, the BEMF coil. That's right. if you really want people to learn, you can't say you need this unless they've come to you for apprenticeship. Can you talk to somebody like that?
Mustang 64 is saying, what are you doing?
Right now I'm connecting a BEMF diode to the battery via a full bridge rectifier. Oh yeah, I need one more clip, but this one can go over here. There it is. Oh my God, it's like it's meant to be.
Meant to be.
I hope that's right, meant to be. All right, so now I will clip the negative up and we're gonna hook it up in parallel and we'll see what happens. We're trying to make this number go up. All right. I don't think I have enough connection space to hook this battery in parallel. All right, we're back in business. We got a little drop off the top. It happens every time. You know, it goes from what it started at to down one. It might go down two or more.
Urban said he's got a schematic he can send you.
All right. I have lots of trouble reading those things, but I'll do the best I can. And the reason the BEMF thing will work, or should work, is because it's offset from the drive. What I mean is the coils are offset. They're never on and off at the same time. And the BEMF coil is over here, and so when it's hitting, this one will be off. So it should go to the battery. But, you know, I'm just testing to see if at 120 this system will work. So far it's working to sustain itself. It's not working to charge. And I haven't gotten a single thing to be able to, you know, be closed loop and charge. I don't think that's possible. And I don't frick all that, man. I did it this way. You go ahead and read a book, man. I'm gonna do it this way. I found out for myself, and then there's people out there telling me that that's not okay. And I'm like, yeah, well,
Yeah, urban studies, he could talk to you about a lot of his experience.
and see, you come to me like that, I appreciate that very much so. And we could talk. That sounds like a good idea.
Nice name.
This is a tuning fork. Let's take a look at some of the engravings on this thing. We got a big vulture. It looks like there's a vulture on the top. Some snakes. Some feathers. So this is like something you would hang on the front of your house, on your door like this. And it would make, it would be like a doorbell or a door thing. Because it's got the little thing for the hook. It can hang on the wall too, but I mean, just listen to it. Perfect for the door. Oh man, this has been my favorite thing for so long,
Yeah.
and it's shared in value.
Never said I'm not self-qualified in anything. It's all software from my
That's awesome. Did you write it down? Yeah, you said you got schematics, so yeah, that's awesome. I haven't written a lot of my stuff down, but I got some notebooks with stuff in it. Now, what I would be thinking is, these are cap banks, not cap dumps. So if we put a cap dump in between the cap bank and the battery, that might be useful. But I think it will slow down the charge rate, honestly, but it'll charge at more of a beefy clip.
I dropped the Papa Bale emoji.
Hey, it's Papa Bale. What's up? Welcome to the channel. Really appreciate you guys. It's not just a thing I say. You keep me going, you keep my mind going. You keep my emotions flowing too. That's good. That's always good.
Blood pumping.
Keep the blood pumping. Make me want to pop off at the mouth kind of stuff. Yeah. So this is a great reading of the coil. This coil right here. That's what's happening on the inside of that. And you really can't get a reading like that unless you clip it to the coil. So it's kind of practical. We got 230 ohms hooked to both circuits. Let's remove the pot. The battery's going to go down. Let's see what kind of speed we can get off of this thing. $230 ohms. Oh, look at that. Very cool. This is zero pot resistance. It's 230 ohms of resistance. That's awesome. I mean, it's a little choppy because it's all being fed through the one circuit, but I think that's awesome.
$3,000 views.
Nice. Wow, that wave is looking pretty snazzy now. Wow. Heck yeah. Now, how much are those? They're like 18 volts a piece, each spike there. And that is with 3 magnet rotor with a 120-degree magnet spread on the rotor. Now they're neodymium cubes in here, but they're stacked on top of each other. So there's a stack of 2 for each 120-degree mark, which adds a lot of like power to the point, to the effect of not needing to spin it very fast and not needing as, thin a trigger. You can go up in your gauge for your trigger from like say 30 to 24. This will do a 24 trigger. The Neo cubes are pretty dang strong, especially when there's 2 of them in series. .26 is good. I'm gonna do another coil with 26 and 24. I think I'm gonna just wrap. It'll end up being about around 2 pounds of a coil. 1 pound for the trigger, and then probably 3/4 of a pound to half a pound for the other way around. But 24 is about a pound, and 26 is about half a pound to make a good coil, I think. With the pound spool, if you want to go up to 3 pounds, then you can make a bigger coil. But it's all based on how big your spool is that you buy, how big your coil is going to be. Well, at least it has been for me thusly. And I bought some 5-pound spools too, man. I've got tons and tons of experimental coils with, that are, big and small. I've had the most luck with using a pound spool from an old wire spool as the bobbin. That's like the proper size, I would imagine, for a 12-volt system. Kind of like this size right here. When I printed that bobbin. That's a special bobbin. Alright, so I'm not getting a good vibe from that. So we'll put those over here. No, I don't want them to touch each other. Yeah, so I obviously hooked up the BEMF wrong because it added a load that didn't provide any energy. So I just unclipped it and we went up in value. But I did play with the pot too, so you know. Let me see. I'm gonna try something. All right, I'm gonna try two things. So I flopped. Um, I don't know if it's gonna make any difference though, because it's going through the bridge rectifier. Both the inputs are virtually the same because they're ACs. Uh, don't know if I really changed anything right there by swapping those. But I could swap the other ones and that'll probably change it. Yeah, I've played with resistors on the drive before, and it's hard to tell whether or not your motor is functioning. But I would say that, yeah, that's definitely a way to cut back on how much you're spending, for sure. Um, and I can do that. We're just going to have to stay within the working parameters. It has to make some kind of noise when it's running. All right, let's see here. Because one way you put the diode, it shorts the coil out. I'm pretty sure this isn't. I'm pretty sure we're right now. This feels good. But the other way shorts the coil out and puts a tremendous load, magnetic load, on the rotor.
a transistor just instantly short without overheating
Yes.
when you added a diode?
Numerous different ways that can happen. If it's on and you add anything and you touch the drive line, you are liable to ground your transistor forever. It'll never work again properly.
And with the shaky table and shaky hands.
And shaky table and shaky hands. Yeah, all you gotta do is ground it when it's on. All you have to do is touch any of that. That's all it takes. It doesn't happen all the time though. But yeah, you can definitely do that. Where should I put this BEMF energy? Huh. Maybe it was working. The way I figure it, I'm only getting like not a lot of voltage, usable voltage from the BEMF. Let's test it. Let's test it. So we'll test the DC output. Well, I'm going to connect it to the diode first. Yeah, that's not a lot of voltage coming off of that. Let me flop these, see if we get a different reading. Oh, pretty much the same reading. But we're going to take this as the way to go. So we're going to connect these. We're going to take the bridge rectifier out of the equation. paint on this diode is like rubbing off. Blue is negative. Ooh, yep, that's not gonna work. And how much did we lose with that? I don't know, I can't tell. All right, so this is not gonna work. I'm just looking to see if I can make it work. No. All right, so I do have a way. Where there's a will, there's a way. What we need is this. Bingo, we're in. It's on backwards, but that's all right. We get the gist. There. All right. And I think I got the BEMF hooked up properly now. Mm. Now, see, this is the thing. Right now, I have the negative line to the battery is just a line, and then the line of the positive has a diode in it. Should I put a diode in the negative line facing reverse? I have no idea. I think it's working, but I don't know if it's working. Might just be working without a benefit, in which case it's not really working.
Oh, I bet this has probably been here for a minute. That is the excess energy you are looking for. How to extract it before that happens is the problem I have. cap 8 MFP.
Mm. 80 micro, huh? I don't think I have one that small. But, so put a reverse diode in the negative line. That's all I want to know right now. We'll do one thing at a time. Or should I just leave it as is?
Yes, before you ask the question, should I leave it as is?
Okay, yeah, I'll do that. Let me find the proper diode. No, I do not have a cap that small. I have, I think the lowest I have is 2200. This is 4700. 4700 is my main number. All right, diode is in place. And there was no ill effect, as far as I could tell. Just put it in the opposite way the other one was going. So if there's any like negative feedback, it will go through that loop right there.
But the power will go down without the cap to capture the EMF from the battery. That cannot be a cap that have a positive and negative polarity.
No, these cap banks have DC caps in them. 20 DC caps. I'm not sure what each one of these microfarad is, but there's definitely caps in the whole system. It's not just a singular cap either. It's a cap bank with bridge rectifiers, and well, you got what it does. It takes AC in and DC in one side, so you can do either or on one side, and it's going to come out the other side crisp, clean DC. That's what these things do. It's done. I think. But this other one, this BEMF connection, I need a small cap, is what you're saying. Let me see if I can find something that we can use. Yes. Might need my glasses to see what's up with this. I can't focus on that for some reason. There we go. I can't use that. Here, hey, bro, can you get a value on this gap? Can you see it? Yeah, let's see it.
Yeah, can you hold it? Or you want me to?
I didn't want my glasses. My glasses here.
Yeah.
No, not those. Here they go.
That's fine, but the AC cap needs to turn the energy rotation around like a dark cap for AC unit or frick. That frick. Yeah, here. I can,
These are 3.3 farad. They're really thick. Lots of capacitance. I didn't think that these little ones would have such capacitance.
that 2.7 volt, 3.3 F.
Yeah, this won't work.
Start cap, not a dark cap, a start cap. Sorry for the spelling, Dan, you spell check. Yeah.
You mean one of these? But it's not AC that's going in there. So it's going to just skip right over those caps. Go into the DC caps. You can put AC or DC into the one side. And it's going to come out DC.
You said yes for that, one of those. Then you said about some stuff, so we'll see what he says to that.
I mean, yeah, I can see putting one of these in there, but I don't know, man, if it's necessary or not. I mean, if I was starting from scratch and it was just a bunch of stuff that wasn't pre-assembled, yeah, I can guarantee I would need all that stuff. And I got most of it. Just, and when this gets going the way it's going to get going, I'm going to reduce the componentry as much as I can. Might set up actually a build. You know what? That's a great idea. I'm going to do an axial flux design that I can package. That's a closed loop system.
It goes. No, it won't just trust.
Sorry? Yeah, I'm all about honesty. So that's awesome. 12.84. It's been there for a while. Turn this off. Now, I'm only collecting BEMF off of one strand in there, and there's a total of 7 strands. Now, I think that the 20 gauge strand and the 30 gauge trigger that's connected to this one, the BEMF is being harvested already. The diode is there to get it, so it's already happening here. And this entire coil now has got BEMF being taken from it. And this coil has none being taken from it. So this is the coil we need to work on. But all the ends are hooked up. So we gotta like double connect some ends, which may or may not work. Sometimes it works okay, sometimes it doesn't. And sometimes you need to add a diode just to make sure that it works. You know what I mean? Just like I just did. It popped, and I'm like, okay, this isn't gonna work. And I'm like, oh yeah, I know how to make it work. We're gonna put a diode there, so the energies don't clash, like physically run into one another. That's really what's happening there when you get all that sparkage. It's not just a short, it's like an opposition. All right, so I got this roll of 24, and I'm holding on to it till I get a nice design for me to make. I'm going to use all of this wire in a coil. Then I got this much 20. So, I don't know what I'm going to do with this. I'm not sure exactly what trigger size, or maybe this will be the trigger. 24 for a trigger. But I want to do 24, 26. So I need to get a spool of 26. And I'm thinking that it would be around 1.25 pounds. 1.75 pounds. So yeah, and then we get, just start making some beefier coils with maybe a little bit thinner gauge, so there's a little bit more beef there. And seeing what we can do with inductance instead of just like raw motor power. That's what most of my coils do. They're like raw. You shove 12 volts through this 16 gauge coil, and you're going to see some action. Look at how compact it is. If these magnets passed this coil, it would saturate it instantly. Depends on what your goals are, And I mean, yeah, most of my drive coils are this size. I don't know why, they just work better. With the smaller magnets, they don't reach as far. So, I made the coil more compact so it would hit more of the coil. That was the original plan about that. And it worked wonders because that was the goal. So that was a win-win because I made the goal congruent with the experiment. So, I mean, but this isn't good. I mean, look at the rust on that core. It's a soft iron core. It's a 1/2 inch in diameter, so most of my axles have been a 1/2 inch. Most of my axles on all my stuff are like a 1/2 inch because of this right now. Because of the core material that I have is a 1/2 inch in diameter. Now, I know there's more to it than that now. You can either get rods, welding rods. You can cut hangers. You can use iron powder. But the idea is to get more than one core in there. It's aligned the same way. Because a single core is a single core. And you're still going to have losses, like heavier losses with having just one core. But, you know, and moving away from the single core theory, it opens up, you know, space for bigger core or a smaller core. And you're allowed to change it now because your parameters aren't predefined by the size of your core. Because I don't know about you, but all I have is a hacksaw, a handsaw, that I can cut that if I wanted to, which I don't want to do. I've already cut several pieces. You know, I got the hacksaw to cut it, and I've cut several pieces, smaller pieces. Oy. Let me think. And that coil that the core is in is a 24 gauge coil, man. It's a fat one too. The only problem is the end of the trigger coil is like right in there. I can still clip stuff to it, but when that breaks, it's done. I have to get rid of it. All my coils end up breaking at the start. Okay, so you can't unwrap them. You have to unwrap the whole thing. You have to start over again. Do they break at the front?
4,000 views.
Woohoo!
Papa Bale emojis.
Hey, hey. So yeah, this is cool. I want to do some more raw electric stuff with homemade reed switches, and I want to implement this along with other terminal blocks to come up with something rather unique. Yes, I have cylinder magnets that will fit. I have to make them specially, but they'll fit. I have to make them so they'll fit. But yeah. You can put these down the middle of a coil. I'm going to see if I can't get a reading off of the electromagnet. You're probably not going to be able to tell, really. So I'm getting the south reading off of the disc, but there's a lot of magnet down there. There's a lot of magnet down there. And there's no action over here. Yeah, I don't know. Start getting to north, like right about here. There's nothing in the middle here. So this is a good coil. It's wrapped north-south. So there's a north end and a south end because there's a 0 point. And the north end looks like it's facing upwards. So that's good because the north end of the magnets is facing downward. So that's a repulsion factor going on right there. So if I were to take one of these long cylindrical neos, I would put this end at the bottom and have this end at the top. But I'm going to make a special bobbin that that'll fit in nice. Nicety nice. Yeah. See, this is all rotor right here. So we go down. Wow. I don't know. Can't get a clear reading on it. There's a lot of north there. Sometimes we'll get a south reading, and I think that's what we're looking for.
Can you make a coil of wire hover over iron?
I have no idea. I would think it would do exactly the opposite. Anytime, no matter which is north or south, when it magnetizes, the iron is going to draw closer if it's close enough. But when you shut it off, it'll fall away. So if you get a perfect, and I mean perfect frequency, so that it'll lift it up and then let it go, and lift it up and let it go before it makes contact, you might have something. But when you lift it up, when you turn it off, I mean, it's got to be an electromagnet. Has to be. So you can turn off the magnetism in proper intervals. But as for making the coil levitate on top of iron, I don't see that as being a thing. It's got to be a magnet, a perm mag, like to do what I think you want to do with that. It's got to be magnetized is what I'm saying. So it's not like iron anymore, it's a magnet.
A magnet.
But yeah, you can turn iron into a magnet, I'm pretty sure. Maybe not by itself, but with an electromagnet, you can definitely polarize iron. Magnetize it, I mean. I'm not sure about polarity, but I know you can make it pick up other stuff, or, you know, it gets magnetized. And it's mainly an attraction thing. I'm not so sure about repulsion. That sounds like it would be freaking awesome just to do off of iron. Crazy cool. But I don't think it can just be iron. It's got to be polarized iron or magnetized iron. Yes. Okay. But unfortunately, the hole in the middle of this one is not big enough to house one of those magnets. So I'm going to have to make a special bobbin, like I said. And I think the 24 gauge and 26 gauge will be the wire that I use to make that. So that'll be sweet. All right, that's a cue. Ooh. I think I'm gonna leave it run with the 1B EMF connection. It's wanting to go down right now, I can tell. But it's still up, so I get that. That's cool. Huh. So in the intermission here, I'm gonna charge up my multimeter in the middle there so we can have 3 of them going. And yeah, I'm taking suggestions. We'll be looking over the chat and stuff. Kinda. I mean,
Let me see if I can just. Let me see if I can. Is it the battery gonna die?
no. I need to sit down, so I'm gonna do that for a little bit.
All right, let's get out.
You want to get some close-up action?
Yeah, let me just kind of get both of the monitors on there.
Maybe I'll bring a chair up in there so that I can sit down next to it.
All right. Doing an all-day marathon? Maybe we'll see after. Like and subscribe. Let us know if you got any comments. We appreciate you guys' support. And there's 2 of us here, and I'm usually typing or holding the camera when I'm feeling better. But now I'm kind of understanding. This is all pretty good. So I gotta be able to fix that. Welcome to the channel, everybody. Like and subscribe. Let us know if you got any questions. We are chilling, relaxing, doing pulse motors. We got some data kicking.
All right. Heck yeah.
That's like the signature right here. And this is battery storage number, voltage. Share the stream. Let others know about Papa Bale's pulse motors. We appreciate you guys. We got 1 level of membership. We appreciate your support.
Yeah, sign up for a little bit, and if you don't have a 3D printer, we can help you out with a 3D print. They won't be free, but you know, with communication, uh, the proper, you know, adjustments or anything that needs to be made to your designs can be made, and then, you know, I can print you out something that you want. Rotors are like a specialty. I like doing rotors. I don't really do anything else. I do stands for rotors. I could probably do something else, but you know, like if you want to do an axial flux or a radial flux with a horizontal shaft, you know. So you have your coil standing up underneath. Yeah, like this particular rotor I like the most, man. It's the best. It's so smooth in the holes here. Bam. I can't even feel it spinning at all. So cool. I can make them to fit the shaft. I can make them to fit a bearing. It's entirely up to you and your design. I don't do thread right now. I don't do threading unless it's in your design already. And then, yeah, depending on, you know, materials and all that, and work out a price, and all that means shipping. So if you got 100% print, it's going to weigh about 1 to 2 pounds. You know, and you got to ship that. So, but that's all, you know, in the future. Communication is key. You know, if you want me to be involved with something you want to create, you got to talk to me about it. And I do like a point A to point B conversation about these things. Literally, like, how are we going to build it? Not what it does, not how it does it, just how we're going to build it. All that other stuff, it doesn't matter. None of that stuff matters to me because it isn't going to get you from point A to point B.
Tell Urban how to get a hold of you.
Is my website on
Oh yeah, the Discord is up on there.
so I think it's on my page. You got the more button.
Yeah.
Or it might be 3 dots. I'm not sure, but there's a more button on my description. I'm not sure where it is.
Go to the channel page, and I think that's right.
Yeah, channel page, and then on the description there's more.
It's like a drop down.
And then you gotta click on view email. My email should be right there. And the Discord is on there too. If that one doesn't work, we'll update it right now.
They said N52 to whatever you were saying.
Magnet. I forgot what I was saying. Could you create a context for the N52? Just kind of hanging out there right now. I want to know what you're talking about. So it's something I was talking about, but I forgot. So, and I was just talking about it, and it really bugs me that I forget like that. But that really happened. I just forgot about it.
It's okay. There's a lot going on. Questions, comments. You got a chill factor. Relax. single strand coils.
Okay. So you use reed switch or Hall effect sensor. I got tons of those kinds of coils too. Nice ones too. 1,500 turns of 20 gauge, single file coils, man. Made to pound.
Well, what experiment are you working on right now?
This is a closed loop dual SSG system. So you got two coils. I'll break down the components. You got two coils. One's a tri-filer, one's a four-filer. You got two circuits. One's an SSG, one's an SSG with gen mode. Okay, and then I'll go through the connections. You got one battery, and you got two cap banks that are also filters, scrubbers, whatever you want to call them, rectifiers, regulators. That's what they do. So now I'll go through the connections real quick. I gotta stand up to do this one. All right, you got the battery, and that goes to the SSG. Then the SSG goes to the cap bank. Then the cap bank goes to the SSG with gen mode. And then the SSG with gen mode then goes to the cap bank. And the cap bank goes to the battery. Without the cap banks, this hookup would not be able to happen. You would start a fire.
Beat is in the house.
What's up, Beat? How's it going? Yeah, Beat.
He's giving some props.
Beat's the man. I'll tell you what. He's got some awesome stuff going on his channel. Should give it a look. He's man, Beat. I gotta get a hold of some of those plastic connectors that you have. You know which ones I'm talking about? That kind of put everything in a line instead of, on a board like this. It's in a line. Those things are awesome, and I can see a magical way of how to use them to make very complex circuits. Like, say you need 10 things connected to your collector. I can see that happening with these strips that you have. Like just on a little piece of plastic like this with some metal in it. So cool.
All right, I got a poll question about how much would you pay for a 3D printed 8-inch rotor? I got 0 to 25, 25 to 50, 55 to 75, above 75. You got 5 votes, 3 for 0 to 25, 2 for 25 to 50. And then Beat says, let's co-create.
Let's do it.
Talk about rotor.
Oh yeah. Yeah.
Or a 3D print, custom 3D print.
Well, I mean, it's going to go by weight. Like if you got a 10-pound rotor made out of PLA, you got to factor in how much the PLA costs and how much it's going to cost to ship the 10-pound item. And that would be roughly what your cost would be. That's just it, everything's going to be fair and straight. It's not going to be all crooked. You know what I mean?
Yeah. We'll make the experience fun.
Yeah.
Cool.
Everything will be planned out, talked about. You send me your design STL files. I'll look at them, we'll talk about them, we'll adjust them together the way they need to be adjusted. Just for a printer, just, it could just be the 0.03 millimeter difference in the size of all the holes you have in your design. And then, yeah, we need to,
So that, what I need to learn to print files, STL, so this might be a co-creation.
yeah,
And then you can build it, you can verbalize it over, Discord or something like that.
yeah, we're definitely gonna have to talk about it. And then, I'll take a look at your files. I'm no expert, but I've made some pretty cool stuff, so I consider myself qualified to run STL files through the printer. To make, I might make a wall adjustment from like 2 wall length to 3, maybe 3 or 4. Just make the wall a little bit thicker. If you want it to be a solid flywheel type device, it's going to be 50% to 100% infill. And then I recommend not making one under 35%, especially if you're going to have magnets on the edges of the rotor. Just a safety precaution. It's all the little things that's fun to talk about, though. If you got little things. It's best ones are the most simple ones, easy to make. Like that one I made with the tri-boomerang style.
Yes, he said choice of the enclosed wall seems good.
Yeah, absolutely. Definitely want some protection. See, so these right here are 100%. They're weak, really weak, but no, actually, I probably couldn't break them with my fingers. Maybe I could. They are really thin, but since they're 100%, they're stronger than not 100%.
That's what K Energy does.
Oh yeah, like this one right here, K Energy. Yeah, I know.
And they remember they might have paused it or something too, so they might be dropping comments, from a different time.
No, I know about what he's talking about. The magnets are like, they're made to fit in and face outward, so it's radial. Well, the Bedini motor is anyway.
And the beat says very high RPM, not always the goal. But thank you so much for this. Yeah, hit us up on Discord or whatever.
Yeah, definitely. Well, we should definitely check this out now and see if the Discord is proper. But click on the Discord and send me a chat. Papa Bale's Pulse Motors. It should look like kind of like a brown and white monkey face that got painted. It's a bipolar painting.
Yeah, the Discord link is invalid.
All right, we're gonna update the Discord link.
X is good. Say hit me up. Send me a DM on X.
Send me a DM on X.
Yeah.
I don't use X.
Oh, okay. Well then.
I'll deal with this real quick.
Yeah, we'll do the Discord link. I don't use X.
I'm not saying anything about it, I just don't use it.
That's right. I don't really.
Alright, so I've updated the.
All right, we updated the Discord invite link. Give it a shot.
Why does it keep reverberating like that? Why didn't it just stay put?
Which one?
Discord link. I've had to do that like 10 times now.
I think they're valid for like 30 days, so we'll see if there's a different strategy, like them friend you and then you send them one, something like that.
Okay.
Yeah, but we'll see if we can do that on YouTube.
Alright, so it is updated currently.
Good job.
Wow, I just had a vision of a brilliant like thing with like moving parts. A rotor with moving like arms that swing. And when it gets thrown by the magnet, and like you get it going, and when the magnet throws it, it's got some more force. That, oh man, that just gave me chills. That's gonna be awesome. Can't wait to work with you, B.
The timing with the other coil is brilliant, Irvin.
Thanks.
Be nice to have a more detailed meter with a more accurate reading in the thousands.
Yeah, I've been saying that for weeks now. That'd be so awesome, because then you could tell whether it was going up or down. Or when it goes up and when it goes down. So,
Oh, you gotta go. You gotta play Survivor Series.
oh no. And yeah, you gotta have a lot of resistance on it. Probably not as much as I have on it right now, but you gotta have a lot on there to extend the life. But you know, the way that I see it is that it falls into a rhythm. Okay, it's gonna fall into it. You're not gonna lead up to it. It's gonna fall down into it. You get what I'm saying? And it is different. There's a lot more involved with lifting something up than just letting it fall. That sounds good. Really. Nope. Well, we're gonna let it drop. I'm gonna put it to 500 ohms on the potentiometer, and we're gonna see where it bubbles off at. Potentiometry.
That's not the one, that's not it.
That can't be right.
That's not the right word. It's not a word.
Now I'm gonna get my pickup coil, because I did notice some energy, magnetic energy coming off the coil. So I want to put my pickup coil. We're gonna start with it like that. Now we just gotta decide which meter.
I'm thinking 6 magnets. I've only used 4 on the spinners. Can't see the link, but look forward to catching up there. Love these live streams. We'll figure out how to get.
Okay, yeah, why don't you just copy it in
Can I
case
post
post.
it here in the stream?
Yeah, try it.
Try to post it.
We're gonna give you a direct link to it. Cause yeah, they kinda hide it on the channel page. It's not on the front of it, it's deep inside of it.
Alright, B and Urban, you can hit up the Discord there.
Alright, cool. So,
You are welcome. I'll leave it up for about 10 minutes and then I'll take it down.
alright. Alright, almost got that coil hooked up to the multimeter. So now this is the pickup coil. Let's hook it up, see what happens. Wow, dude. That is freaking cool.
Yes, sir.
That is awesome. Wow, dude, I'm blown away. So this is that little black coil next to the big coil on the multimeter over here. And that is 27, 26 volts peak to peak, and it's just sitting next to the coil. So there's a lot going on right there. It's kind of sitting next to the permanent mags too. Permanent. So let me move it. Wow. Now it's getting hit from the perm mags too. Like, wow, look at that, how distorted that is. That is amazing. It's got a really good sine wave going too. It's just a really like bumpy one. 42 volts peak to peak now. Just from moving it that little bit. But now it is under the rotor a little bit too. Oh,
Hello, buddy. Papa Bale.
so tightening up the resistance chokes that a little bit too. So it's 29 volts peak to peak now. But we're gaining on the battery a little bit. So let's do BEMF off of this coil. Just need to take a second. I think I'm just going to swap the wire connectors. I gotta make,
Super chat, $1 from Christopher.
yo, Chris, what's up? Just got the BEMF hooked up. Let's see what we can do with it. So it looks like it's rectified. Whatever's going on is above the line here, or the artificially made line. Neat. That's cool. So that is rectified. Brilliant. But my hypothesis is that it might even go down faster now. We'll have to see, but this is the wave that's coming off that little black coil right there. Just from sitting next to and underneath the rotor. And it's sitting next to the coil and sitting underneath the rotor. See that static right there? That distortion up at the top of the wave? That is coming from being next to the coil. And the wave itself is coming from being underneath the rotor. So there's two pulses going on right there for sure to generate that wave on that coil. And it is plugged in to the battery right now. But why isn't that a good thing? Is what I want to know. What makes it work opposite the way that it would logically do so otherwise? This is why I think some things are laws that are meant to be broken, and some things are you can't break them. We'll see. See, that's going down. I'm going to tighten up the resistance a little bit.
Quantum mechanics.
Yeah, I always get right down in there, and it's like within a thousandth of a volt, and stuff is going on, and you know it's like it's a big battle's going on in that volt or that thousandth. Like, who's gonna win? Who's gonna lose? And I think I don't know. Honestly, I think it's nobody, no side. It's not even about people. It's not a body. No, it's not about a body. It's about the positive and the negative are always at odds, but neither one ever gains the advantage. But it's exactly the opposite of what I just said, but exactly the way that I said it. So it's like, if you think of it in ways of magnetism, the opposite and the negative and the positive attract, right? But I don't think it works that way for like maybe it does. At least the way you connect it, it does work that way.
The other side of the energy cannot be observed.
Not with a meter. Not with a meter. That's so true. In many different ways. I mean, if I hook the multimeter up to this point, I gotta check something. And since I've stopped it, I might as well put those other 3 Neos on here. Yep, I knew it. Hey, I'm glad that I stopped it. I gotta put that in there better. All right. So I was thinking, like, put one more Neo on top of each one of those, and then put this cap back on. So what do we think?
Here,
What's that?
should have thought of that a while ago.
Thought of what?
Here.
What is this? Can I talk into it?
No, but you can see what's going on live.
Oh. Yeah, I'm not gonna read that.
Okay, okay. No
I
problem.
mean, I wanna know what's being said, but like up there would probably be better.
It would be better on the giant screen. Yeah.
So maybe you can, put your phone on the screen?
Oh man. In a minute.
Alright, so. Right here, this houses my Neos.
Yeah.
It's a little bent and out of shape, so I'm not using it. But I'm gonna take 3 out of here, put them on there. Wow, that's awesome. Yeah, I hear you, Urban. That's definitely my fallback, man. My eyes are going, they're going. Nah, it's a good idea, I think, but I don't know if I want to do that right now. Maybe, maybe. Just taking them apart, it might be a trick, but I think I can manage. Ooh.
What's this?
What is it? Good Lord, it's definitely.
Alright. Beat is in the Discord.
All right, sweet.
Started a thread, 3D print options. And I'm new to Discord, so.
No, that's cool. Hang on there, B. We're almost done. All right, so that means you get rid of this for right now. Yes, that looks good. Better than it did.
This is a great idea, the custom 3D print rotor. Thanks for the feedback.
Heck yeah. Can do pretty much whatever you want. And 8-inch parameters. And then, getting a bigger plated 3D printer is another thing that I want to do. I have two 15-inchers, but they're old school. And they're not working that right. They're just not working right now. That's all right. Let's see here. Yeah. Woohoo! And now, I don't know, it gives it more style, I think, to have the two discs separated like they are now. There's a little bit more magnetic energy in there. So you can have a little bit smaller trigger if you wanted. Like a smaller gauge. Or, I mean, a bigger gauge. I'm sorry. Less return on your, well, I just think this is going to be good. I could probably use a 24 gauge trigger with this. Wow, that is so cool. I can't see the magnets anymore. All right, so that's that. Let's see where we're at. 83 still. It's a nice wave we got here. How much voltage is coming off of that? Like 15, 16 volts? Heck yeah. All right, so I think I want to wrap it up. I'm not sure exactly. I want to talk with Beat real quick. See, give him my contact info so I can get a look at his rotor and talk about it. It's a nice wave. I love that wave. Gonna spend some battery juice real quick. love it, man. So cool. Yeah, I spent some battery just to see it go a little bit faster. All right, I'm gonna lock it up real quick. So if it goes back up to 12.83, it's good. It's solid. Well, I might have spent it though, just now. But I'm gonna leave the resistance the way it is. All right, I'm gonna leave the camera rolling for a minute. So, all right.
Yeah. Alright, okay. This is good. This is a great screen. Chris and I,
Hell of a-
Dwarf King Vortex.
Dwarven King.
You love pulse manager, vortex. If we could visualize the vortex, Dwarven King, vortex,
Yeah, the banner vortex.
and then got the war cry coming out.
It's kind of like one of those sheets of music in those old pianos, the automatic pianos.
Automatic piano.
It's a great mechanism, but without that sheet, it just doesn't do anything.
He said yes. Excellent, excellent work. Almost at 5K,
Yeah.
4 hours.
That's good. That's about right.
Really good. I mean, it's good. My motors use SM and polarity.
So you use your magnets in both poles. That's cool. This one right here is a north-south polarity. It's a 12 magnet design. A little tiny one too. It's like, all right, I'm gonna try something real quick before I take off real fast and check my Discord. I'm gonna move this out here. Then I'm gonna tilt it on its side and Let's see what happens. Okay, so it just looks like it doesn't have as much magnetic. What happened there?
What happened?
So that's south. That's negative. That's way below the line. That is weird. That is cool though. Here, let me lift it up to the 0 point. Oh, I wish I could see it. I'm gonna look at it though later. And I'm gonna move it up to the north. Really close to the magnet now. Here, let me do this. All right, it looks like it's dying. Multimeter. Yeah, okay. I see what's going on. I gotta plug it in. So I guess that's a good time for me to call it for now. That's awesome. Thank you so much, everybody, for hanging out. I really appreciate it. Please get a hold of me on the Discord. The link is active currently. And please like, subscribe, and have a wonderful day. Bye now.